In example 1, I want to simplify the following expressions without using any negative exponents if they appear. So in this product that we have, you can write this out as much as you need to, but I like to take the approach of multiplying the numbers and then each individual variable. So we have a -3 times a -5, which gives me a +15. Okay, and the next thing we come across is we have an x in the first one and an x cubed in the second. So if you'd like, you can actually just write those two directly next to each other and even indicate that there's supposed to be a 1 in the exponent of the x. And then the last thing is the y's. We have y squared, and then we have y to the first after that. And once it's written this way, it's just a matter of simplifying the variables as much as possible. So the 15 will stay as is, but we have x to the first times x cubed. So we have 3 x's in one of them and then 1 in the other. So we can just sum those two exponents. We're saying we have 4 x's being multiplied together. And like for the next one here, y squared times y to the first, well, that's a total of 3 y's left over. So it's 2 y's followed by 1 more. And this is our simplified answer, as there are no negative exponents. Okay, for this next example, here we do have some negative values appearing in the variable exponents for a and b, actually in both of the pieces being multiplied together. When we multiply these, again, we could start with just the numbers. So we have 0.5 times 16. And I know that's the same thing as half of 16, which is 8. And then, next I guess I'll write this out as a to the -1. Then we have a cubed. And for b, it's b to the first, and then b to the -4th. So that way I'm placing the variables next to each other, and I'll go from there. For the a's, let's see, the 8 stays as it is, and then we have a to the exponent of, it'll be -1 plus 3, so it's actually going to be a +2. So there's no negative value there. That's great. That's simplified as much as possible. But for the b's, we're going to have b to the, well, it's 1 minus 4, so that gives me a -3. So this is combined as much as possible, but this b to the -3, it can be moved to a denominator. So you could write this as I have 8, I have a squared, and then I'll multiply this by 1 divided by b cubed. So that's a completely fine way to write the answer. If you'd like to write it as one fraction, that's acceptable too, because you could consider the first one as having a denominator of 1. And since we're multiplying two fractions together, that's going to be 8 times a squared divided by b cubed. And feel free to jump to that last step. So if you're starting here, like this whole thing is divided by 1. So you could have just put that b cubed into the denominator immediately, but there's nothing wrong with this middle step as well. So this would be our final answer, as there are no negative exponents. And in this example, so here we're dividing as opposed to multiplying, but same rules work. Let's see. We could really break this apart into like 3 separate fractions if you want to. You could say, well, this is 125 divided by 5. And then, well, now we have an x cubed divided by an x to the first. And then we have a y to the first divided by y squared. So that way you can just like isolate each term and simplify them as you go. So for 125 over 5, that's going to simplify to an integer. That's going to be a total of 5. And for the next two pieces, when we multiplied variables together, we added the exponents. Here, when you're dividing, you're going to subtract the exponents. So this is going to be x to the, they'll be a little more careful, and I'll say this is 3 minus 1. And for the last piece, it's going to be y to the 1 minus 2. So we're not adding this time, but we're subtracting. This is how we're saying we're canceling any common factors. And when we simplify this, we get 5. We have x squared, and we have y to the 1 minus 2, which is -1. So here's again a situation where, okay, the y has a negative exponent. I'm just going to jump right to this last step where I know this whole thing is divided by 1. I'm just going to put that y to the negative 1 into the denominator. So it's going to be 5 times x squared, all divided by y to the first, which I don't need to write. And that's our final answer for this part. The last couple of examples here are going to start combining all of the rules that we have. So they're going to look kind of complicated, but for this one here, I'm going to focus on distributing this exponent on the outside to every single term inside the parentheses between the numerator and the denominator. You don't actually have to start this way. It's completely acceptable to first simplify within the fraction and then get your answer from that. But I think what I'm going to do is for every single exponent, I'm going to multiply it by 3. So just to be a little bit more careful, this is really, 2 to the first, x to the first, y to the fifth, over 3 to the first. This is x to the negative 1, and then y to the first. This 3 on the very outside is multiplied to each of the exponents that appear with inside the expression. So I'll have 2 to the 1 times 3, which is just 3. We'll also have x to the power of 3. But now we have y to the 3 times 5, which is 15. All right, I'll divide by, okay, now we have 3 to the power of 3. We're going to have x to the, okay, negative 1 times 3 is negative 3. And then we have y to the power of 3. And this is what we have to simplify. Okay, I think what I'll do is deal with the 2 cubed and 3 cubed. 2 cubed is 8, and 3 cubed is 27. And I think I'll do that trick again where I'm going to break this up into 3 fractions in total. So that's going to be, we have x cubed divided by x to the negative 3. And then we have y to the 15th divided by y cubed. I think the last 2 fractions will be straightforward, but if we look at this one here and we're thinking about how we subtract the exponents, it's going to be x cubed minus a minus 3. So actually those two are going to be added together. That's going to be 3 plus 3, which is 6. So as I go across here, I'll start with the 8 over 27. I can't simplify anything there. There's no common factor, so I'm going to leave this as is. But then x is going to be to the power of 6. For the last fraction, I'm going to have y to the power of 15. But we're taking 3 from 15. So if I'm looking at this fraction here, that's y to the 15th minus 3. So that's going to be a total of 12 left over. And this is a completely fine way to write your answer. Again, you could write this as the whole thing is divided by 27, but this is fine. It's a number times x to a power, y to a power. There's no factors to cancel, and I'll leave it as this, as the final answer. For the last example that we have, it's going to be a little confusing with this negative exponent of -2, which appears right here. So there's several ways to approach this one problem. I'm going to take one approach, but it's not the only way to do it. I think what I'm going to do is I'm going to move that whole expression to the denominator. So I'm actually going to write this thing as a fraction. So like this whole thing here, because it's to the power of -2, that can go into a denominator. And the other piece over here is going to be in the numerator. So this is going to look like we have 2 times a squared b, and this whole expression is squared, and that's divided by, okay, now we have, so this is going to be -3a squared, but now to the positive 2. Okay. I think at this point, I'll square out the numerator, the denominator, and then try to cancel any common factors after that. Not forgetting that 2 is to the first, so is b. And this is a part where we have to be a little bit careful. This -3, it's like the whole thing is to the first, even that negative. So when I distribute the 2 to everything, here's what I get. I have 2 squared. I have a to the 2 times 2, which is 4, and I have b squared. This is all divided by, this is really -3 squared. Because you could think of it as squaring both the -1 and the 3, but with parentheses, I can do it at the same time. And then I have a to the 4th again. So you could use subtracting rules again, but if you're comfortable with doing it this way, we have an a to the 4th in the numerator and an a to the 4th in the denominator. Those two things are identical. I mean, obviously, if you subtract the exponents, you get 4 minus 4, which is 0, and the whole thing completely cancels. But I'm going to take this approach and just cancel them both like this since they're identical. And simplifying just a little bit more, I have 2 squared, which is 4, and I have b squared, which is simplified. And this is all divided by -3 squared. Well, that's just -3 times -3. It becomes positive, and we get +9.